So here we have a typical exam question. We have an astronomer waiting until Aldebaran, which is a star, is due south, and they are measuring the angle above the horizon as 64 degrees and 30 arc minutes. Now, as you hopefully remember, the angle above the horizon is called the altitude. The name doesn't make a huge amount of difference for this question, but it is definitely worth remembering. So we have the altitude of our star, and we need to show that the declination is 16 degrees and 30 arc minutes. Now, the declination is simply the angle above the celestial equator. We are told to use the observational data given above, which I'll show you in a second, and we also need to include a carefully labelled diagram. So the observational data is from part A of the question, and it basically just tells you where the astronomer is. We're not going to go through part A right now. That would be the subject of a different video. We are simply going to concentrate on converting between declination and altitude and back again. The only piece of information we need from this part of the question is that Rome has a latitude of 42 degrees north. Now, hopefully you can remember that the latitude that you are at is the altitude of the north celestial pole. We're going to open up a whiteboard so that we can draw a diagram nicely, and we'll go through it step by step. Hopefully, this sort of question will become a lot easier. If you have a latitude of 42 degrees, then the north celestial pole, which is basically Polaris, so the north celestial pole will have an altitude of 42 degrees as well. So if you're in the northern hemisphere, whatever your latitude is also your altitude of the north celestial pole. Now we are also told that this star is due south. And using this information, we are going to find the declination of the star. All right, so declination is the angle above the celestial equator. So declination is the angle above the celestial equator. And we have already said that altitude is the angle above the horizon. So the first thing I am going to do is I am going to draw our horizon line. So this is going to be our horizon, and I'm just going to label the right side as north and the left side as south. We'll put a line at 90 degrees, pointing straight up, and that will just point to our zenith. Zenith is simply something that is straight above you. We now know that our north celestial pole has an altitude of 42 degrees. So let's draw that on. Let's just put a dot here, and this is going to be our north celestial pole. And the north celestial pole, same as our latitude, and it is the angle above the horizon, so that's 42 degrees. The next thing we're going to do is we are going to draw on the celestial equator. Now, the celestial equator is at 90 degrees to our line connecting to the north celestial pole. There we go. So this red line here is our celestial equator, and the black line we drew originally is our horizon. Let's do some simple geometry before we put the star on. So we know that the angle between the north celestial pole and the zenith, that's this angle here, is just 90 minus 42, because the zenith is at 90 degrees to our horizon, so we just take 42 degrees away from 90. So 90 minus 42 is 48. Now we look at the 90-degree angle between the North Celestial Pole and the celestial equator. So using that, we can have a look at the angle between the zenith and the celestial equator. 90 minus 48, which is 42 degrees. Finally, we'll look at the angle between the celestial equator and the horizon. So this is 90 minus 42, which is 48 degrees. So we know that our star is due south. That means that it is going to be past our zenith, and it has to be somewhere within the left-hand side of this diagram. And we also know that the star is 64 degrees and 30 arc seconds above the horizon. Now, the celestial equator is 48 degrees above the horizon, due south. So we know that our star needs to be between the celestial equator and the zenith, and it needs to be 64 degrees and 30 arc minutes above the horizon. So let's just write that angle on. So this is 64 degrees and 30 arc minutes. Now, if a star has a positive declination, it is above the celestial equator. Above, in this case, meaning on the half of the celestial equator that is closest to the north celestial pole. So if our star is to the right of our red line, which it is, it's going to have a positive declination. If it was to the left of our celestial equator, it would have a negative declination. So it turns out we are looking for this angle here. Now this is the angle between the celestial equator and our star. This is the declination. That to find this angle, which is just our declination, all we need to do is take our angle of the star from the horizon. So that's 64 degrees and 30 arc seconds. And then we minus the angle between the celestial equator and the horizon, which in this case is 48 degrees. 64 minus 48, 16. So we've got 16 degrees and 30 arc seconds. So we have now found the declination of our star. Now, the second part of this question comes up quite a lot in exams. You've got your declination, which the astronomer in Rome has found, and now you are told of a new location, in this case Oxford, which has a latitude of 51 degrees and 45 arc minutes. Using this information and the declination of the star, we are going to find the maximum altitude of our star. It's worth mentioning that declination of a star is the same no matter where you are on Earth. So declination is independent of position or location. Let's call it location. Location on Earth. Whereas the altitude of a star, that depends on your horizon, which does change with your location. So altitude is dependent on your location. So looking at this, we know that the declination of the star is going to be the same. It's going to be 16 degrees and 30 arc minutes, but the altitude of the star is going to be different. Let's start as we normally do. We're going to draw in our horizon and a zenith, like so. Zenith, horizon, north, south. Next thing to do is to place our north celestial pole. So this time our latitude is 51 degrees 45 arc minutes. So our north celestial pole is 51 degrees 45 arc minutes above the horizon. 51:45. We now draw in our celestial equator, which is at 90 degrees to the north celestial pole. And now we can fill in the angles that are missing. The next thing we need to do, we need to put our star on the diagram. Now, declination is the angle above the celestial equator. So there are two places where the star could be 16 degrees 30 arc minutes above the celestial equator. The first one is over here, and the second one is down below the horizon. But in both cases, the angle between your star and your celestial equator is 16 and 30. Now, for this question, it's quite obvious that we're going to want the one that is above the horizon, as we can't actually see stars when they are below the horizon. But it's worth mentioning this because you will get some cases where it's not quite as obvious. And we'll go through one of those after this question. So we've now got our star plotted in the correct place on our diagram. To find the altitude, this is the angle above the horizon. There we go. So all we need to do is we add the declination to the angle between the celestial equator and the horizon. And this is going to give us 54 degrees and 45. Let's look at an example where it can be slightly less obvious as to which position of the star we want. So let me just get rid of this. We're going to stay at Oxford. So I can keep my diagram the same because I'm still at Oxford, so the North Celestial Pole is still in the same place. But what we'll do is we'll look at a star that has a different declination. Let's say our star has a declination of 70 degrees. And we want to find the maximum altitude of our star. All right, so if we didn't have this diagram, we'd draw the horizon and the zenith, plot the North Celestial Pole and the celestial equator, and then fill in these three angles. Seeing as we've done that already, we can skip straight to putting our star on. So we know that the star has a declination of 70 degrees. So the angle between the star and the celestial equator is going to be 70 degrees. Once again, there are two places where this can be. So let's just put the first one here. There we go. And this large angle between the star and the celestial equator is 70 degrees. The other place our star could be is on the other side of the North Celestial Pole. And then the angle between our star and the celestial equator is again 70 degrees. Now, these two positions are what we would call the upper transit and lower transit of the star. So, as you probably know, stars will rotate around the North Celestial Pole, and then the highest altitude we call the upper transit, and the lowest altitude we are going to call the lower transit. In this particular question, we are looking for the maximum altitude of the star. So we are looking for the angle which is biggest between the horizon and the position of the star. And that is going to be when the star is at this top position here. And we are looking for the altitude of our star. Once again, remember, altitude is just the angle above the horizon, is this angle here. And a bit of simple geometry will let us figure out what this angle is. So the angle between the star and the North Celestial Pole is just 90 minus 70. So this is just going to be 20 degrees here. And then the angle between the North Celestial Pole and the horizon is 51:45. So the altitude of our star is going to be 20 degrees plus 51 degrees, 45 arc minutes, which is just 71.45. If we had been asked to find the lower transit, so let's find the lowest altitude, it would be very, very similar. So instead of being above the North Celestial Pole, our star would have been below it, over here. So to figure out the lower transit of the star, we would do the altitude of the North Celestial Pole, which is 51 degrees 45, minus the angle between the star and the North Celestial Pole, which is 20, giving us a lower transit altitude of 31.45. So that is the end of our 3 examples, and I very much hoped that helped. Good luck in whatever exams you have next, GCSE, A-levels or university. It's a very odd topic, this one, gets covered at a lot of different places. So good luck to you all, and I'll see you again.